Okay, so we've started the recording. And I will show a screen. I will show a screen in a little bit. Pardon, I've got the wrong towers in the screen. I've got some old-fashioned the G 1.5s from a site in the background. But in any case, yeah. So the system itself. Let me go ahead and grab the one I have. We will. Whoops. This is the box. This is inside here is a power conditioner, A to D card, voltage divider. It's capable up to 1,000 volts phase to phase. We have had somebody on a new tower out in California accidentally apply this to a 6 kV tower. And they said they got readings on the first test, but it stopped working after that, and they didn't know why. That's basically the limit as to what happened. So it's well insulated, lots of space in there. It is actually built for nuclear power facilities, so it's pretty robust. There is, you'll see with the kit and also on the front, there's a spot for ground. Take the ground lead, put it in an office drawer somewhere where you'll forget it, and don't use it. Because one of the things that'll happen is if you have that plugged in and you're at a tower and you're running low on your laptop and you plug that in and there's a lot of noise in ground, you have the potential of generating a ground loop. You don't want that. So I always just leave that out. We only ever use that if I'm looking at a system like a single phase machine where I don't use phase to phase between 1 and 2. Or a DC motor where I might just plug in to 1 and then reference it to ground. But even then I use 1 and 2. As long as I'm taking voltage in on 2 points, I don't need to worry about ground. So don't do it. Is that good? Good.
Okay.
So 1, 2, and 3 channels on the top. So you've got channels 1, 2, I'm sorry, 1. Yeah, channel 1, 3, and 5. Odd channels are current for those 3, and channel 2, 4, and 6, those are voltage. That's also nice to know because you can export your data and it'll show up as those channels in basically a CSV. There's 2 additional channels you probably noticed. This one here is actually set up so that these are actually for taking in data from vibration. Your system is a pass-through, so you can use those for collecting whatever you want. They're BNC basically, plus or minus, I believe, yeah, plus or minus 10 volts. So all of these are plus or minus 10 volts. So it's a millivolt per amp type setup. So if you need to, or you want to use, say Rogowski coils, if you have a grouping of conductors and things like that, you don't have to come to me for it. It'll be way too expensive. You can go to Amazon or you can go to whoever and get one as long as it puts out a millivolt per amp rating. But you do have to remember when you do that, take a look at its response because like the Rogowski coils I have are only good from 0 to 3 kilohertz on viewing. Plug this back in. The other parts, if you go through everything, this is the only part that's not easily replaced. Okay. The other thing is if you do make a mistake and you do blow a card in here, you're not going to have to buy a whole new system. We'll end up repairing the card for a fraction of the cost of a new system if something goes horribly wrong, like you apply it to 6,000 volts. Another thing we just learned is that in a latest update of Windows 11, Windows 11 no longer gets along with a USB that wants the 5 amps that this wants. So I'm working on getting around that. It's going to be a just an update. By the time we do the class, I'll cover that. So if you use the PC that came down with the unit, do not upgrade it to Windows 11 yet. Until we finish up the tech note on the workaround for the power supply. It's One of the things Microsoft did so that they could claim green is limit the amount of current coming out of the USB ports. I don't know why they did that. It's gotten a lot of equipment and other manufacturers who rely on the output of that upset. So we figured that out, I think within a week of them putting that out, because we started getting tech support calls that something wasn't working. We've gotten everybody back up and running. So if something goes awry, contact us. We're here to help. If for some reason we are totally out of commission, there's a number on the thing. A company by the name of Framatome is the OEM. Framatome is a nuclear power services company. They don't have a lot of field experience outside of nuke. So we tend to manage most of that. But basically, there's a $12 billion company behind the technology. Let's see, what else? We've got some 12 kilohertz. We got that. The warning about the laptop, which I never had to give out before. That's recent. Yeah, and then we'll be in touch. There's going to be that software upgrade. It will be coming soon. The really nice thing is there's really not too much you have to do with it. You just install it and it writes over the executable. As soon as we finish testing it, there's a couple of things done. There's an emphasis on some of the wind stuff. It actually tightens things up so that it's a little more accurate. Unfortunately, the programmer got over enthusiastic, and it now alerts you to everything. There will be some additional settings you can make for tightening or loosening the data analysis, but it'll be a little easier too. You won't have to manipulate the screens as much, which I like. More screen manipulation, the more time, and when you're going through, like I did the other day, 200 turbines, that adds up. Okay, so that was a quick view of that. Let's see. The CTs that are with it, those are replaceable easily through, I don't know if you use Amazon or Fluke or whatever else, as long as there's a millivolt per amp rating. The connector that goes between the PC or laptop and the device is literally a printer cable. There's no magic to it. It is a printer cable. So if you're in the field and something goes wrong and you can get a printer cable, you can be back up and running. Say you close a cabinet and you cut it in two or something like that. It is nice. The one that's there is robust enough that when I go into turbines and we have to have the door closed, like if it's a spot where I can take data down tower, and we want to have the door closed, we can hook up and close the door because the knife edge there usually has a gap in it. Things like that. Yeah. Okay. I think those are the main things. You guys are primarily taking data up tower. We'll get to that in a little bit. This version of the software, they're talking about now putting a password on future versions of the software. It still will not limit the number of people who can access the software. It's just to prevent the software from being shared with competitors. There's some companies out there who are trying to figure out how we do things. And we all want that security there. So all that would end up being is a phone call saying, hey, I want to be able to access the software, and the key is provided, and you don't have to keep entering it. It stays with that system. That's something else to be aware of. I just learned about that yesterday. But that may or may not come out with this upcoming version. The present version, 8.0D, works really well for all of this already. And if you have access to a copy, go ahead and put it on your computer and you can play with data right away. There's no limitations on that part of it. There are some things you want to put in to be able to do data collection, and that's what we're going to cover. So I'm going to cover that first. And if you don't have some of this already, I believe you do because you're taking data, and I've seen those things. I've seen the nameplates already fully set up, which is nice. Here, and I'll show you this. Okay. So in the C drive, there will be a folder called Framatome. By the way, I have a tendency to talk really fast. I'm Canadian. So if I'm talking too fast, my Portuguese, even though I grew up in St. John's, Newfoundland, my Portuguese is really bad. If I have to slow down at all, just say, hey, can you slow down, or could I repeat that? Okay, don't, yeah, I talk fast even for here. So in any case, when the software itself is installed, it creates a folder. Right now it's called EMP80. Ignore the rest of these. This is all stuff related to what I'm doing, and this version of the software really is really horrible for what we're doing. But EMP80 is the folder. This is the operating system. There's some sample data in there. Don't worry too much about that unless you're interested in three-phase machines. It's pretty old data. The EMPW.exe is the executable. That's the software itself. If somebody has something go corrupt in their software, that's basically all you need. This is a standalone software. You could literally take that folder, give it to somebody else. They can put it on their computer and start up and run. It does not require any of the DLLs or anything from Windows. So EMPW.exe is the software if you ever have to go in and start it within the folder. This one here, SCH.exe, for what you're doing up tower right now, the way you have it set up, that is an important software. That's the scheduler. And then down here, you won't have to run this. Whenever you run the scheduler, this one here called Watchdog starts up. Watchdog, basically, if the software locks up for any reason when you're doing the data collection, the automatic data collection, it will reset the software and start it over again. So it doesn't sit there just locked up. You might miss one or two data sets if you're set to collect data every 5 minutes, but that's about it. It should reset after about 60 seconds. So SCH.exe is the one we'll have to go into this folder to get. I usually say pin it down here. You can see I have it pinned right here. If you are installing the software, which should be on a USB, on a different laptop, or actually even on the one you received, we don't start them up anymore because now Windows also requires that you set it up for yourself. So we send that down ready to go, but not, as a new laptop, but not turned on yet. Or you want to install it and run it from a different one. There's another folder, there's another software on there called Instacal. Instacal, and that's the reason I plugged my thing in. That's this one right here in Windows 10. It will be under, let's see, MCDAC, I think. Measurement computing is the folder of the under in Windows 10. Measurement computing is the maker of the A to D card. And that software, which is right here, when you start it up and you've got a data collector, it will identify the board in there. And this one, it says board number 0. That's because we can have up to board 99 if I'm doing a, basically 100 boards if we're doing continuous monitoring. So just leave it that way. That way you don't have to do anything else special. And the rest of it just identifies the type of board and the serial number. So once you start it up, it'll pop in like this. That's it. That's all you need to do. That links the data collector to the PC or laptop. You only have to do that once. Now, if you have two EMPATH systems, I've got 4. If I have 2 of them, if I switch between this one and the other one, I'll have to run this again. So that's why it's pinned on my thing. Otherwise, just use it when you need it. So if you send the device, but you don't send a PC with it or a laptop with it, when it arrives and you have to install, just remember Instacal. That's it. If we run into problems in the field and we're helping you troubleshoot, yes, Marina?
Sorry, Dr. Hardy, where is it, the Instacall?
Where is Instacal?
Yeah.
In Windows 11, it will show up as Instacal after it's installed. It'll be on the USB as well. And then once you've installed it, if you're in Windows 10, it'll be under measurement computing in the software, in your software list. Okay, so measurement computing right here. Ignore this. I've got a whole bunch of other stuff.
Finding the measurement computing here. I installed the software.
Yeah, there should be two. Yeah, you don't have the other one. If you want to put it on your computer and you don't have it, you don't have the USB nearby, you only have the software, you can go look up, actually just Google Instacal. It'll take you right to and take the latest version, which also makes it available for Windows 11. Yeah, it's freely available. It comes with an MC DAC card, which is now National Instruments, which is now Eaton, or Emerson, I'm sorry. But in any case, it's still out there if you lose or you don't have that USB nearby. And then once you do that, you connect to the system, it'll run. Okay, so I have a whole bunch of different types of these cards for other instruments I use. So got other things running in the background here too, or available in the background. It'll basically just say Instacal. If you're going to be swapping back and forth between multiple units, I usually just pin it so I can get it. Once you've opened it and it's linked up, you're done. The only other time you might need this is if you were to call and say, hey, I'm having a problem. Yep, Diligent. Diligent's where you purchase it from. Diligent's owned by, they changed hands all of a sudden. It was like 3 months where National Instruments, MC DAC, and somebody else all got purchased by one company, including Digilant, which they're little, well, they've got some cool stuff too. But in any case, the only other time we do anything in here is if I was going to troubleshoot, I might, if we're talking, I might have you call it up and I'd be going through doing some testing or whoever, to make sure that something's not happening to the card. So before having to ship it all the way back to the States, we can literally troubleshoot the system remotely, as long as we have access to be able to see the software, or we may walk you through it. Okay, so that's that bit there. Once you're hooked up, then the instrument's hooked up. And you'll be able to start the software up. Oh, I started the wrong one. This will be the new version. I'm going to end up closing this. Bear with me a second. You don't want to see the new one yet. You'll be all disappointed with the one you have. Okay. Let me go back here and find my. I got a couple of different versions because I teach some folks that also are using older versions of the software. Here we go. It's going to start up on a different screen. I'll move it over to the screen we're looking at. There'll be a splash screen that comes up first. It says EMPATH, Framatome, should be a blue screen when it starts up. And then there may be, like just now, because I had started up Instacal, there'll be a gray box that says, hey, this is the system you have and everything else. It says just press OK. And then it'll come up in a screen like this. The first time you start, it's going to be somewhere random. If you have not had the software on your system before, we're going to go through the setup folder. I'm sorry, the setup first. And you probably won't see this little nuke button over here. That's for the continuous monitor. I'm going to show you how to turn that on. So when you come in, the first thing you're going to do is see this. You want to go to File, Setup Options, which I just remembered. I forgot to show you something. Let's go back in here. Let's go back to C. in the USB, another very, very important file you'll see is a .box file. So just okay. Is what's called a .box file. That .box file is the calibration file for the device. Okay, so this one here that I have is 375. So so that's the box file, the calibration file for my device. Okay, so the first time I start up the software, I'll come in here. It might show some random number or temp, whatever. I need to match up the serial number of the box and that .box file. When you first install the software, you won't have that in that folder. That comes as a separate file. You take that and just dump it in that folder. Just straight C Framatome. Then in here, check everything else.
Sorry, Dr. Harder, the
Yes.
box file, I need to open it?
No.
What should I do?
When you go into File, Setup Options, File, Setup, Setup Options, this will open up. Once you put that into that folder, you would just select that.
Okay,
that
but it
calibration.
will automatically to the folder?
No, you have to take it from the USB and put it directly in the folder. If you lose track of it or whatever else, there's no issue. Email us, we'll get you a copy. We keep them on file.
How this file, I will receive it with the equipment?
Yes, with the equipment, there'll be a USB file, a USB
Okay.
in the box. That USB has the latest version of the software, has the .box file and everything else. I had the unit sent here first. I went through and verified everything was there before we went through everything to get you the system. So we shipped it from here and made sure that that was all there. And I did that because a new shipping guy had sent out a couple of them without anything on those USBs. So we made sure it was populated and you have all the data on there. So once you do that, yep, you make sure you select that serial number. If you don't have it, there's this temp folder there if you want to play with just pretend data, that'll show up. But basically for data collection, you want to make sure you have this. Otherwise, if you go out and you're getting really weird numbers, like the voltage doesn't match, like it's 0.1 volt or something like that, then chances are that this is not connected. So that'll be if you ever call us and you have something like that, that'll be the first question. It's like the good old fashioned, my computer's not working. Well, did you plug it in? Okay, so I'm just teasing. Don't feel bad. I mean, I still run into things that I start going nuts and then I go, oh, wait a minute, I forgot to do this really simple thing. But in any case, so make sure all the check boxes are checked there. Under acquisition, uncheck calibration warning. That's really annoying. The other thing you want is some versions of the software, for whatever reason, the programmer left it as this is 1024. You want the FFT block to be 65,536. The reason for that is to get the resolution we want, especially when the machine is extremely lightly loaded and everything else, or you're trying to discern whether you've got a blade pass frequency going on for the blades or a problem going on with the wiring. Okay, because those are going to show up almost in the same region. So it's one of the things I watch for is am I seeing a pole pass frequency or am I seeing a blade pass frequency? So we do discern that in the software. But to get that resolution, it's one of the reasons why this is the tightest resolution you can get at 0.005 hertz. So we can distinguish definitely between the two. So all this other stuff, if you want to have those checked or not, that's up to you. Do keep start acquisition all modes selected, keep that one checked. The more important ones, and then analysis, make sure that 65,536 is there. Having all the lines in black, that's up to you. I usually don't, because then if you call up and you say, hey, I've got something really weird, and it's the blue waveform, and I can tell you, oh, that's phase 1, or the red wave, that's phase 2, the green one, that's phase 3. Okay, that kind of thing. Although you can fool me and change those colors. And by the way, any changes you make on this version of software you have on the laptop you're using stays with that laptop. It's specific to that laptop, and it doesn't affect anybody else's. So everybody can have an individual set of settings in here. So it's kind of nice. These things down here for what we're doing, do not change any of that. It doesn't matter whether you're in a 60 hertz or 50 hertz environment, just leave it as default. High frequency download length, leave it as 9. You'll start filtering out some of the things we're looking for if you select 46. It'll also double the amount of time that it takes to collect data, which in this set, in the configuration I'm showing you, is 48 seconds. Leave this one here as DC value only. That's the default. Now, coming down through here, I usually just check everything. You see I have display unidentified peaks right here, unchecked. That's because if it sees a signature that looks like a bearing, so say I don't know the bearings in a machine, I can check that, then it will look for any frequencies that are non-integer multipliers of the running speed. In a wind turbine, there's a lot of signatures that are non-integer multipliers of the generator speed. So you do not want to have that checked for a wind turbine. Otherwise, you'll just get a lot of nuisance flags. Checking the rest of this stuff is good. And then one that's really important is on this one. Yeah, just that. And then I think it's on 2. This one on 2, display extras tab, you want that. And then there's another one here where it says double default down, low frequency download sampling rate. You want to make sure that's checked. The reason why is because we've got 2 sets of frequencies, low frequency data set and a high frequency data set. If I don't have that checked, I only go up to 90 hertz. But to see a lot of the bearing issues and stuff like that, including the gearbox, I want 180 hertz. And that's what that does. So basically everything on here should be checked. Don't worry about these 2. They don't do anything. And when I was talking about those colors for the channels, that's this here. So if you want to go through and you don't like the colors, or I literally had somebody who was colorblind, needed to go through and change some of these so that they work for them, so they could see the differences between the waveforms. But in any case, the default is blue is channel 1, red is channel 3, green is channel 5, and similar colors are for voltage. And then this last one here, these are the settings. Okay, so for this one, it's got some pretty good default settings. For wind turbines, I always set the amplitude to -70. Here, the default is -65. It's going to give me some false positives, but I prefer getting false positives, so I'm looking. So if it might call that something's bad that really isn't, but I want to go and take a look. We'll go through when we do the class, we're going to go through what levels to look for. I'll show you what a signature looks like today, but in particular, so I'll set this at -70. I'll reduce this down to 5%, especially seeing as you're going to put this up tower and have it do data collection. And everything else basically stays the same for this version of the software. Now, there's one more tab that's not showing right now. And for that, I use these 3 fingers and I push down Control, Alt, and Enter, and something called a hidden folder or a hidden tab shows up. In the present version of the software that you have, this will go away in E, but in the present version in D, and by the time we get to the class, I'll be giving you E. If I come in here, to get this little button over here, that's the Enable ECMS button. Now that means EMPATH Continuous Monitoring System. My data collector or the continuous monitoring single channel or the continuous monitoring 32 channel all use the exact same software. So that means that the system that you have can be used for collecting data over time. So if you're troubleshooting something, you can set up triggers, you can set up all kinds of other things. When you do that, you want to create a folder called a communication folder. You don't have to call it the COM folder here, but if I double click, I can go down and select whatever folder I want to call it. That's where all my data is going to reside, up to so many sets of data. I can also do a second folder or a backup folder. This will keep for each one up to 1,000 sets of data. So we use that for when we have continuous monitoring set up. For doing the type of data collection you are, the numbers you put in here doesn't really matter. And then if I put something in this ECMS remote folder, I'll say allow second copy. The other ones don't play with. That's all for somebody requested that stuff somewhere else, and I have a hand up. Fazio?
Yeah.
Maureen, I'm sorry.
The communication folder.
Yes.
It needs to be at the root of the.
No, you can put it anywhere you want. Don't put it into like if you have a synchronizing folder like a OneDrive folder for this primary communication folder, don't do that. Because if there's a lag, you'll corrupt the file, right? Because it's constantly streaming the data. So all 12,000 samples per second for each, because that's for each channel. So you're taking in 12,000 samples across 8 channels coming in all at once. You want that to go straight to the PC. So if you do it, like I do mine on a OneDrive folder, but I have the EMPATH data going into a OneDrive folder that's always present on my laptop, right? So it's always staying on the laptop with a copy in the cloud. Good news is the data sets are not large. You're only talking about a small data set might be, on average, it comes out to be about 2.5 to 3 megabyte per data set. They're not massive. Each channel is separate. I'll show you what that looks like in a second as well, in a little bit. So in the setup, you want to make sure.
Just one more question.
Yes.
There is any reason for it to be a hidden?
For this to be hidden?
Yeah.
More so because now, because some people use just the base software for continuous monitoring in the plant. So one of the things I was just working on was recently was the application of 100 machines at the plant that makes Reynolds aluminum foil. One production line, we're monitoring 104 machines, including some DC stuff. All that comes into 3 boxes, 3 ECMS 32s, and then some ECMS E1s. So some of the people have access to this software, and we don't want them going in and changing where the data is supposed to go by accident. So you call it a hidden file, so there's an extra step. If you're going to go in and make changes, it's deliberate. Right, so that normally doesn't show up. The new version of the software, it's automatically going to have this little nuke button. There's some other cool things in there, but we'll go over that when we go through the class and I give you the latest version of the software. This part here where it has the channels 1 through 9 and then a number in there, don't do anything with that ever. I had somebody going, oh, I changed it to no. It never goes well. But anyways, so that's there. basically that's for the guys who are setting up the system at the factory or at the OEM. So don't play with that. These two checks here for channel 7 and channel 8 Excel, those are for if I have the vibration accelerometer cards in there. So those you won't need. Oh yeah, that's right. This is not my latest version. I would have these checked for that box. So if I do put a second folder, that can go anywhere, including like when I go out in the field and I have something set up and I want a share folder somewhere, I can use Dropbox, OneDrive, whatever I want, and have that one saved there because it writes to this one first, then writes to this one. Yeah, and that also means, by the way, when you're collecting data, if you get a box that pops up and says, do you want to save your data? That means your data is corrupt. If you don't see that, that means it saved your data. It does that automatically. So when you go out and you're collecting data, you should not, if you're doing it manually, you should not have to do anything else. So that's the basic setup. When we do the training class, we're going to go through all of that again with a little more detail under the new system. I'm going to go through next the nameplate data setup first, which also means if you don't have it, you should have it because you've been sending me up the Winergy one. But these USR files, actually, I'll send you the instructions for this. Although, if I haven't given you powertrain.usr, I may do that anyways. That's based on the Mitsubishi one. That's basically every possible configuration for a wind turbine, with the exception of a double planetary system. So when we go back and set up a machine here, I start out on this screen and say I want to set up another nameplate other than this one. I'll come in here. I'm gonna, and by the way, these folders are just straight Windows folders. I sometimes suggest if there's a lag, because on my computer, because I have so many things running in the background, when I try to set up all my folders in here, like say I highlight this and I say, okay, create new folder, which is clicking new. It'll create everything as if I'm putting into a regular folder, but there'll be like 10, 20 seconds delay each time I do that. If you want to set up a whole group, you can go straight into a Windows folder like this and create your hierarchy, and you're all set. Then you can go back to that folder because this is just going to list all the folders. You can see these are not EMPATH folders, and you can then go from there. Once you've set up your folder and you highlight it, then you can set up a nameplate data set. I'm going to just do that for our purposes here. You want to type it in here, no spaces. If you have to have a space, do an underscore, right? So temp 1. I don't even recommend that sometimes because you never know, right? Spaces are not friendly in this part. So I try to leave out spaces. So I put in whatever and I click enter or the checkbox. It shows up here. This comment is also part of the nameplate section. So when I come in here, highlight it. If you don't highlight it, it'll say like divide by 0, or it'll keep giving you errors until you highlight it. And if you're wondering if it happens, yeah, I did it to myself the other day. So you highlight this one. Now, if you don't have nameplate data, never fear, you can always enter the nameplate data afterwards, but you'll have to do it on your individual data sets, and that's not fun. So you want to try to get everything you can in here. So let's go ahead and I'll do basically exactly the same data that's in this one here. So highlight it, smiley face. Angry means I want to shut down. It'll say, you sure? You know, challenging you. That's why angry face, I guess. Don't ask me. I didn't create this. Happy face, that'll be nameplate data and some other stuff. You'll hear me call this sick face. It helps remember what they are. This is all my channels. So we are going to cover that here in a second because I want to make sure that all my settings are correct. Once I do it for one, so you've got all these, say, this is from one of the ones, this is actually data you sent me. So this group here, once I set up one, and if they're all the same machine, once I do this one, I get it correct, I can right click, copy, and then I can go to each one and paste. So everything I do in here will follow it. So highlight it, happy face, it pops this up. Usually would default to induction machine. So for defig, always select asynchronous generator. It is specifically set up for defig. You can use it for all other turbine types that are not synchronous. So any type 3, but not type 5. So any of the type 3, yeah, actually, type 5, couldn't you? We'll find out. Anyways, once I set that up, I select that. These should set up for a wind turbine. There's these checkboxes here and other checkboxes. Yes. Question.
Yeah, I have one data from Chic as well that I'm trying to open, and when I click at the happy face, I receive an access violation.
Yes, that's because you haven't highlighted that line. So make sure you highlight this.
Yeah.
And then click on that.
It keeps saying the same access violation.
Then it's either then it may be corrupt.
Okay.
High paths,
The path is too long, the address, maybe is that?
It could be, or it could be located somewhere. I mean, if you're trying to access it off the cloud, if it hasn't finished synchronizing, I have run into that.
Yeah, okay. Can be that, yeah.
Yeah. If it's not on your computer and it's still synchronizing and it's a partial file, because it's looking for, there's 3 files in the folder. I'll show you what those are in a little bit. So when you share it amongst people, there's, say if you want to send a data set, if you want the nameplate to go with it, there's 3 files you need to make sure you include. We'll cover those in a minute. So I highlight the temp. Then I click the happy face. I've got my asynchronous generator.
There is one data that I was able to click the happy face and it opened channel 1, current 1, another kind of box, yeah. Just with the channels on and off, transducer sensitivity.
Showed it like this.
Yes.
That's you might have accidentally clicked sick face.
Sick face?
Yeah, the blue one. Blue one is the channels. I call it sick face.
Yeah. No.
Yellow is happy face.
Okay.
Yeah.
Okay.
Yeah. Sorry about that. So there's some really neat stuff in here, an induction motor. So say we did this with your US team on the on some of the yaw motors. We did these as induction machines. It's a different type of setup and did a few other things, included some of the gearbox information and so on. But what we want to do is come down here. It's going to keep going back to that until I click OK. But I come in here and then I will put in my kilowatts or horsepower. I can't change this to kilowatts. I've asked them to change that. This is a number you want it to be as close to what the actual is as possible. You know, so if it's actually kilowatt, put in the kilowatt value there. And then here, this machine should be 2016 RPM. This will be off the nameplate, 690 volt. Current is 1520. It is going to do something that I really hate. It does this. So it automatically goes and says this is about 1/4. I will always change that to some number that's lower. If you are doing a yaw motor or something, you can always change this also to a fraction. You can put 0.01 there. That basically sets the base load. If I'm doing continuous monitoring, or if I set it up in the tower and I wanted to collect data, you want that current to be less than what your unloaded current is going to be for the tower, so it collects data. Rotor bars are the rotor slots for a defig, or rotor bars for a an induction machine. We use that because that is going to show us certain signatures in the high frequency spectrum. That will
Sorry,
identify things like
Dr.
software. So yes,
Can you repeat, please, the rotor bars? What are they going
yeah,
to be?
that's either rotor bars or rotor slots. So in a defig, which is a wound rotor generator, you'll have slots versus rotor bars. In an induction machine, you'll actually have copper bars that go through the length. It's the same thing. As a matter of fact, it sees it as the same thing. Whether it's coils or an actual copper bar in there, it's rotor bars.
Okay, but it's not a nameplate information, right? So if we don't have this information,
Yeah, if you don't have the information, leave it as -1.
okay.
And yeah, and if it's a newer machine, it's possible that it might be a little difficult to get a hold of. But if it's an older machine and you can't get a hold of data on it, I have contracts and so on with all of the repair shops in the United States. IPS, well, it used to be Evans, IPS, Shermco, and a few others, and they provide us data. So if you call up and say, hey, I need data on this type of generator, and I don't have it in my library already, I'll provide that. So if you guys have a contract with a site and it's not a Siemens generator, we can probably get you the information. And then, of course, the stator slots. Why these are important is this is going to provide some of the data we need to know to identify the Y-ring / tab issue. And stator slots helps us identify things, especially in certain wind turbine designs, will identify wedge issues. So when we do the class, I'm going to go through what a wedge signature looks like. So some of the ABB turbines, for instance, they were manufactured prior to 2010. There was a very specific date range. They'll lose their wedges. Certain other generator manufacturers, same thing. And there's a very specific signature, so you can identify those before the disintegrated wedges start burrowing their way through the insulation system and cause a short to ground. That was the investigation I did along with Acciona back in 2010. CT and PT ratios, you will actually use CT ratio. If you go in and you have, say, 6 conductors per phase and you clip around just one, like you will probably be stuck with that. Well, then you put down like 6 there, right? Or if I'm on certain towers which have 3 conductors per phase and I clip around one, I would put in 3. It's your current transformer ratio, and that's basically, if I go around 1 of 6, that same thing as having a 6-to-1 CT ratio. Is the current is evenly divided. Well, not always evenly divided, and I say that because sometimes when you do it that way, you'll get a loose connection reading, and that's because one conductor might be carrying more or less current than it should be. if it were evenly split. Voltage will be balanced across all three. So whatever that ratio is, whatever the number of conductors, I can take a look at this one after. So once I get this part set up, if I am leaving the box up there, I will want to just call it whatever and whatever folder it's going to go into. Right. So box 00 will always remain 00 if you're using a data collector. You can change this position if you have multiple. Yeah. Oh, I'm sorry. No, I'm wrong. Sorry. Yeah. 00 and 0. Always leave it like that. Don't worry about the line frequency resolution. If you really want to do anything, just 0.01. And then the next thing you need is this for a wind turbine. Under model number is our super secret spot. So that .usr file, when I come in here, if I double click in here, it'll show it. The ones that you've been using is the Winergy, which is kind of a generic file that I use. Or if you use this one here, it's going to show all the positions. You notice this up here is now changed from bearing to powertrain. So if I click in this will have all of the bearing positions first, including generator, and then it'll continue on. Here's all of the gear teeth information. So these are all bearings. There's a gear teeth. If I go in there and I want to change, the bearing, and I double click on it, please wait because I got too many darn things running in the background. There is a very, very, very extensive bearing database with this, which covers virtually all bearing manufacturers that are relatively common, not just here, but elsewhere. If you don't know, use SKF. The reason why is because SKF kind of dominates the standards group for ABFMA, and everybody kind of follows their lead. So if you don't know, use that. And then you could type in, let's say, what's that, an NU. And as I put that in, or I can select it, but it's a very large database. And then it'll find it, click on it, click OK, and it'll populate that spot. And it'll put in all the multipliers. So that's inner race, outer race, cage, and ball spin. So that means that when it identifies a problem, I can identify the component of the bearing that's causing me trouble. That becomes important when we talk about lubrication related issues, especially on main bearings. So for instance, I can literally tell you if you're having a problem with lubrication, like somebody didn't properly flush a bearing, that kind of thing on the main. And then part of the project we're doing now, when we're looking at ground systems, we're also looking to see if we're seeing already fluting damage on main bearings. So all of that will show up, by the way, from your generator data. I love that part. It's like, how is that possible? Because we're seeing the whole system all at once. And then, of course, up here, these are your gear information. So if you have this information, fantastic. If you don't have it, we have agreements with Gearbox Express. And if they've ever worked on a gearbox of a particular design, they will provide us that detail. If you have access to it, great. A lot of the gearbox manufacturers so far have not had a problem sharing the information. So this is important. This is part of what I'll be talking about on powertrain. So in addition to the work that you guys are doing, watching for wirings and stuff like that, you're actually going to be looking at the whole thing. And we do the training class. I'm even going to be able to tell you how to take a look and see if you're having problems with the transformer. There's a certain type of transformer and certain towers that are having some issues. So anyways, get that in there. Ignore list as if I'm doing up tower stuff and I can check and uncheck certain alarms. Don't worry about that for this. So these are the two that you want right there and there. Once I have that set up, I want to keep this highlighted, and then we'll go into sick face. And yeah, so the data clamp, or the clamps, I'm sorry, the current clamps we provided, there's two. One's 1,000 amp clamp, that's the big one. Chances are you're gonna be using that most of the time, unless you decide to take a look at, like I said, you can take a look at, yaw motors and so on, just like the generator. Then you might use the smaller set of clamps. If you do use the small set of clamps, you notice there's a switch on there for 200 amp and 20 amp. Always leave it on 200 amps, which is first off 10 millivolts per amp. But if you go to the lower setting, most of them that have that switch, when you go to the lower setting, it passes everything through a little circuit and it ends up filtering out some of your data. So always leave it at 200, no matter how low you're going. We're looking at collecting the data. We don't care exactly what the value is. So 1, 3, and 5 are current. So if I'm setting up for the first time, I always check and make sure that those are reading the same. These values here, this is going to go away later, but it'll be this. This has to do with setting some of the gain stuff. As long as they're balanced, you're good. If you're not, set it for 1. And then if these are not selected, I'll only see 1 phase. So how I get those numbers under here, I want to match current to current. So I'll click, left click, and drag 1 under 3 and 5. And then under 2, I'll left click and drag for voltage. That way, when I'm collecting data, when I do the data collection part, I'll have all 3 phases laying on top of each other. That gives you the ability also to take a look. Now, if I want, and I want to have all 6 just show up, I could just turn these all on, and then I'm going to have 6 positions showing up as I'm collecting data. Really noisy, but you can. I mean,
Sorry.
yes.
Sorry, Dr. Hardy, I didn't understand this part.
Okay, so this
So,
this is for when I'm getting ready and I'm collecting data. So let's go ahead and I'm going to open this up. You can only do this if you have a box attached. Okay, so if I open this up, when I turn it on, if I'm connected, I'll have 3 phases of voltage showing here. Or I want 3 phases of voltage showing here, and I'll have 3 phases of current showing here, so long as I have 1 under 3 and 1 under 5. Now, if I want to, I can change this. And have all of them show up as individual, right?
okay, so I'm not setting the channels that I'm going to collect the data. I'm just setting how I'm going to view it.
Yeah, all 8 channels upload all the time.
Okay.
Just what.
Yeah.
I
Yeah,
thought
so I could
thought it
literally
was
do
for
this.
collecting the data.
Yeah, I'm still collecting all 8 channels if I just have it
Mhm.
set up like this. It also determined how it's displayed later. So when I set it up like this, all 3 phases are always going to show up. When we go through analyzing data in the class, we're going to play with this a lot when we're looking at things. So, okay, you've got a noisy channel, or you've got 1 or 2 phases. Whoops, I did that wrong, didn't I? Yes, I did. There we go. So those are all 3 phases of current, all 3 things. I mean, if I really want, I could put, the 1 under all of them. And I'll have voltage and current sitting on the same thing. It doesn't matter. It doesn't affect your analysis. This is your display. So as a matter of fact, as long as you get the data in, you can do whatever you want in viewing the data. And you will not affect the base data. But yeah, when we get into data analysis, if I get 1 sine wave and 2 square waves, say it's a GE always does that, really low wind speeds, their controls do all kinds of crazy things. to the gains of the instrument. So it's not the tower, it's the instrument doing things with gain. So I might end up with really odd things. As long as I get one that's a sine wave, I can analyze that one. So I get rid of the other ones because they're just noise. So in any case, when we get into this part here, this is how we end up doing our data collection stuff. Yeah. This is one of the ones that you would set up. Okay. So far, yeah, we have that. Oh, actually, I should have gone into that. So we have that, we have that. Let's go into here. If I'm just doing straight data collection, I'm not having it collect data for me. I'll show you that first. Because if you happen to be in a tower, I mean, some of your towers, we go in to some of the Siemens towers with the induction machines, and down in Texas, I just take the data off of the UPS, the charging circuit to the UPS. There's a panel and there's a 3-phase circuit there. I get good data off of that. We're primarily doing voltage signature. So in any case, when we're here, when I first open this up, I've got a couple of approaches I can take. One is I can set it to trigger. And that's this here. If I set trigger, I can set a current value. Say the tower is not running yet, and I just want to grab a set of data. So I set the trigger value, in this case, to about 500 amps. Then I can click download. They'll say, how long do you want to collect data? Must have collected data for 94 seconds the last time. I don't want to do that. And the pre-trigger, so once it hits that 500 amps, it'll collect data from 1 second before it hits that. I can change that value if I want. This is basically what we call inrush data. It will only show certain things. I don't do it normally unless I'm looking for problems on startup. Normally, I will use download. There is one other thing that that you can do here too, is, and this again is if you're actually at the machine, you're collecting data, or you're doing it remotely. Okay, and that is this button right here called Spectrum. The other buttons don't play with too much, but Spectrum, if I click on that, this changes this to amplitude versus frequency, and this is in linear right now. I can change this to what I troubleshoot with by doing layout. We're going to cover this again in the class, but I just want you to see it because I've done this for troubleshooting. If I go log, spectrum, and layout, this changes this to dB, just like what we troubleshoot, and it's got about a ½ second scan rate. So it will go through and I can watch all of my signatures live. And then one, if I'm troubleshooting something, it won't collect the data. It's just real time, just like this. I can watch the signature. I can watch the waveform. I can do whatever. It's not till I press this download button here that I'll actually download. So going back, if I'm getting ready to download and I'm doing it as data collection, not the way that you guys have been doing it right now, but if I go into a tower and I'm able to connect up and I can collect data manually, I'll come in here, I will set the gains. You see it says set gains, and then there's a second option underneath, it says set gains and phase. I can right click, and so whenever I right click on a button, it gives me options. Okay. So it sets gains and phase, and so on for this button here, which is the same as clicking on F8. F8 or this button will adjust the gains in the instrument, and will also help if I have something out of place or if I have something backwards. It's going to show me the RMS current, the RMS voltage, the order that I have my current probes in relation to my voltage probes. So phase 1, phase 2, and phase 3. Sometimes those might flip. And then I watch for my power factor. That's the third one. So I want to rotate these until I get to a high value of power factor. The other thing it's going to do is it will adjust my amplitude here so I can see the entire waveform. So once I say, okay, this is good, I click yes, and then it'll show me a waveform. If I want to slow that down, I can speed it up or slow it down. So you can take this where we were. And you can see I'm basically right now I'm reading ambient noise, or actually whatever's on my USB. Because I have this thing coiled up next to a monitor. So once I have that, I can come up here and click again download, and it's going to download for 48 seconds. And while it's downloading, while it's running, it looks like I'm pausing a little bit. Sorry. I've got so many things running on this laptop, it kind of bogs down when I'm data collecting.
Dr. Howard, when we connect to the EMPATH, it start to collecting the data automatically?
No, when you initially connect to the EMPATH, you have to manually go through collecting data or set it up to automatically do it. Bear with me 1 second. It's 48 seconds before it finishes. Stop me 46 seconds. I'm going to let it finish. Down in the lower left, you'll see a thing that'll read up to 100. It might kind of give me a hard time because I downloaded 0. Downloaded nothing. Yeah, there it is. If I get it floating point 0, it means there was nothing there. And then it'll update this. If I did it correctly, it might have just given me corrupt data. Yeah, it's complaining now. Okay, so I'm going to go through one more thing here real quick. So basically, once I have a database set up, if I'm collecting data, again, not the way you guys are doing it right now. I think do you guys have a written instruction for how you're collecting data up tower? When your guys set up?
Yeah,
okay.
well,
I'm not going to vary that at all. It's basically setting it up as a continuous monitoring system. As a matter of fact, I'm kind of concerned about walking through it in case I change something, because what you guys have been sending me is perfect. Whatever
Okay.
you're doing it right. If you're just going out data collecting, say you walk into a GE tower or somebody else's tower. Sorry, I keep saying GE. They're like 52% of the towers here. I think you guys are second or third, right? So we want that to change, I'm assuming, but in the US. But in any case, so when I come in and I get everything set up, first thing I need to do, once I have everything set up the way we had set it up already, and I have my nameplate stuff and everything set up, I plug the instrument into the PC at least the first time. Unless I turn off the PC at any point or attempt to collect data and it's not plugged in, you want to make sure that your cable is plugged into a USB port. If once you've set up the Instacal, it's always set up. You don't have to do that again. You just connect it in before you start the software, though. If you don't connect it and you start the software, it's not going to link, and you'll run into some errors. Starting up on my other screen. So you then start the system up. And then once you're started up, you would say, oh, why did I bounce over to that one? Oh, I see. I was playing with data. data from last year. Here we go. There we were. Okay, so come in here. And if I click on this and I have sorry, something. There we go. I click on the folder where that nameplate data is. Once I'm in there, all the data, if I do this manually, will stay in this folder. It won't go into that subfolder. So if, once I come in here and I have the machine, I double click on it. It's going to pop everything up because I have everything checked. It will show this as well, which will give me a rough idea. When I'm doing wind turbines and I'm doing it manually, I'm always going to run my gains first to make sure everything's nice and even. Another thing I can do is right click my download. Oh, I'm sorry, you right click that, but I can click on download at that point, and it's going to start downloading my data. Going to hit escape to stop. That's the only time I should see, do I save that data? If I hit no, it deletes it from that folder. So that's manual data collection. Biggest part is setting everything up. Once I have everything right, by the way, I didn't cover this before, I don't think. And I want to have this same one in the next one. I right click, copy, and then I can go to the next folder right in here, right click, paste. And I'll move that with everything that I set up in the first folder into the next folder and so on. Makes it really nice if I have 100 towers I have to do and they're all the same. Even if they're not, if I have 100 towers and all the generators are the same, but the gearboxes are different, then I can put all the generator and then just go through and just change that one file on all of them.
And so it will create the files inside the main file that I created.
Yeah.
And
it
the
will
name
name
of the
it.
file,
Yeah, so if I name it temp like I did back here, it's going to call it temp 000, and the next one will be 001, 002, 003 in the order that I collect the data. So I'll be able to know which one was first and which one was last. It will also timestamp it until I send it to somebody. So if you send it to somebody and you unzip it, it will show the unzipped time and date, not the actual time and date. Just keep that in mind. But if you write it and say you keep a second copy in some remote location somewhere and everybody accesses it, it'll have whatever that date is.
okay, so I collected the first tower. And
Yep.
I name it the file with the name of the tower.
Yep.
Then when I go to the second tower, I copy and paste and change the name.
Yeah, you just click on it. So you want to set up each tower as its own folder.
Yeah.
And then when you go to the net, so the first one we just did, if you're doing data collection, first one you just did, you would click on this one and then you would go in here. The next tower, I would click on the next tower and I would run it from here. So this one here would all save into that second tower. If you're going in the,
how
yes.
you said we can copy and paste to have the same settings, right? So
Yeah,
I
yeah,
don't
so-
have to repeat.
Right, you don't have to enter everything every single time. That takes forever. A couple of years in 2017, when I was going out and doing complete sites, I had to do every tower. And it just drove me nuts. So I took the guy out to dinner, the software, one of the software programmers, and I said, I really, really, really would like to be able to copy and paste. So he set this up. And in fact, looking at some data. Let's take a look in where we were just looking. So you can see right through Windows, I'm going through each step. So in here, we didn't save anything in here. These are just nameplate things, the stuff you sent. So I come in here, and this is that data we just took. So the nameplate data is up here, everything that says temp. This says temp D, temp H, and temp.ste. That's all the nameplate information. That's everything we had set up. This one here, this is each channel for high frequency, which I haven't shown you that yet. So this is each of the channels. And then this is all the channels for low frequency. So, and by the way, the dot, that's channel 1, dot 2, dot 3, all the way through channel 8. 11 is kilowatts, that's a calculated channel. So that's automatically being created each data set. And then the dot H down here, did he keep that? I think he kept that. That's a summary, that's all your findings. If you really want to, I don't know if this will show what. Let's see. So, yeah, no, it's an ASCII. It's not a regular ASCII file. Okay, so anyways, yeah, so if I wanted to send this temp data, you can see the file sizes, right? This is all the data collected for channel 1 is 211 kilobytes. That's how many ever rows in a CSV file for 12,000 data sets over 9 seconds. And then I would just click like that and send that. If it's 001, I can highlight these 3 and then all of them that have a 001 associated with it, and that would be that data set and so on. So if anybody ever says, hey, can you send me over the data set you're looking at? That's it. That's how it's set up. So for each data collection you have, this is the nameplate, and then this is all the channels and all of the findings. And again, like I said, relatively small data sets. Which also, because it's relatively small and I'm not dealing with gigabytes, that also means if I go out in the field and I'm far away, just like I believe you do here. Whoops, my bad. Do that. I'm going to do this. Just like you guys did here, there's more than one data set. Now that's because you set it up to continuously monitor one, but here's the date that I opened this up. Okay, so there, these would normally on your laptop, those should show 3 separate times. And then, but you can see 000, 001, 002. If I want to just go straight to the high frequency data set, I click this up and down arrow, and that high means that's the high frequency data set. So then if I just open one of these up, end up with this. That's low frequency. Whenever you hear me say low frequency, and then this is the high frequency data set. Oh, I opened up the new version of the software. So this is going to show current, voltage, and power. Yeah, so here's current, voltage, and kilowatts. Yeah, this is 8E. I was wondering why I was showing 4 on the other one. Let's let me open up the right version of the software that you have. Show you what those look like. Sorry about that. Chance to shut down because otherwise I'll have 2 copies of EMPATH open, which you can do. So the version you have, when you open up a data set, it's going to show this. If you want to see what the software thinks the conclusions are, come up here and click this. When we go through the data analysis, I'm going to show you some really cool things that occur. In DFIG in particular, here's what's fun about DFIG is the way that a DFIG works is you've got a constant frequency in the air gap. And just remember this, we are not analyzing the rotor. We're not analyzing the stator. We are analyzing off of the air gap. That means regardless of the wind speed, the air gap is going to be at a constant speed, whether I'm at a low load or a high load. So if this particular machine is turning at 2016 RPM, the air gap is actually 1820. And that's how it's generating a constant 60 hertz. A little different when I'm dealing with an induction generator, because that goes through an inverter. But on our defig, everybody's design ends up at a constant speed. If it goes a little faster, it changes the output frequency. If it goes slower, it changes the output frequency. And you can actually look at the frequency that it selects to determine where you're going to be roughly. But when I go through a site and I say, okay, you know, somebody set up all of these things and it just so happens to be about 1820 RPM, and they basically cut and paste the programming from tower to tower to tower, they're all going to be 1820 RPM. And the other nice thing is matching up that peak to a pole pass frequency. A pole pass frequency will not relate to anything else and will show up in both current and voltage. This, for wind turbines, if there's a very definite set of signatures in current, voltage, and my high frequency data set in dynamic eccentricity, it'll give you a score on the Y ring. Y ring can be Y ring, tab, or brush circuit, meaning slip rings and so on. And when we go through the data analysis class, I'm going to show you all that. There's a reason why the power spectrum shows up in the newer version of the software. That's one of the things we looked at before. I always kept it hidden, but now the software program, now that he's a programmer, now that he figures out how I do towers, is trying to make it easier. And, you know, he's making it easier. So anyways, results there. Time is the raw data. It'll estimate motor load. Frequency is going to be the line frequency, whatever it's selected for running speed, what it's selected for pole pass frequency, any harmonics. And then here under whatever you had set up, say Winergy, or in this case, powertrain, green means bad in this case. And I mentioned colorblind earlier. The programmer is literally, by the way, colorblind. He meant to make this red. I told him to leave it that way. It sticks out. So, and I told him this was not green in the background. This was actually seafoam. But in any case, yeah, so it'll say confirm proper operation. Here's what's cool about that. If I see something like that, I can double click it. It's going to throw up cursors associated with that condition. That's going to make your analysis much, much easier. And for those wondering why it's going to be so easy to actually analyze the data when we get to that point, it's because I do this too and I'm lazy. So I want it to be the easiest way possible. So when we go through the data analysis, you're going to see all the shortcuts that I have built into the software. So it's going to make it easier. You're going to understand why those peaks exist, but we're going to talk about the fact of the software. You're not going to have to sit there with a calculator. Which is nice. Phasers has to do with any harmonic content that exists. And extras here it includes, well, right now in the version you have, it'll have the torque spectra. It might be, if E doesn't turn out right the way I want it to, we may stick with D for the time being. They dropped this out of E. I like it. This is actual air gap torque. And by the way, I didn't point this out. This here, you see it says foot-pounds. I forgot this. If I go to settings, if you prefer to do everything in, say, newtons or whatever else, you can switch this over to SI. Right there. It just changes that, and the calculations are different. So, I haven't shown you the other method of setting up because you have a written instruction on doing it. That involves needing that nuclear button. That also involves changing some things each time. If I walk through it, I'll probably confuse it. So at this point, any questions on this? Okay,
Nope.
everybody feel comfortable with the basic setup and data entry and so on?
For me, I wanted to know what's the main settings that we can't change after collecting the data, and what can be changed after collecting the data. So what
Oh.
we need to be more careful
Okay,
before.
so if you go in and say you collected data and you had no nameplate information in there, you just did the default, which you can do. When you open up the data set, by data set. So if I open up this one, there's two other data sets in this folder. If I make a change here, I can change the header. It's going to change my data. So if I go in and I say, you know what, wrong one, I need to change it. I go, whoop. Wasn't right. I go to test info. I say, I actually meant to put in the Winergy. Press OK. It'll change the analysis. So,
So what can't be changed?
what can't be changed?
Yeah.
Yeah, as long as you're staying in this part, you can't cause any trouble. If I needed to do a more serious change, you would have to go into here and you would literally have to start changing numbers in here. And don't do that unless there's something very specific we need to do. So for instance, if you had things set up incorrectly, say you had 1 millivolt per amp in one and you had 10 in the other two, and you meant to make it 10 on each one, you would go to the other channel and you would select the X, copy that, go back to the first channel, paste it in there. You have now changed the actual data set. It will go back through and recalculate everything. So you don't want to do that unless you have to. There's also ways, if you've inverted a channel, of re-inverting it to where it should be. I'm just going to say it should be so infrequent that you do that. There are step-by-step instructions in the manual for it. I would rely on those. But yeah, other than that, if you're going in and you are looking at this data yourself and you're just using all the viewing and you highlight things and you put lines in and or you change position, that's specific to your copy of the software. It's not going to change the data in the database. Basically, every time I open the data, it pulls up the raw data. That's partly how we keep the data set so small. And it also means that you know, if you set it up one way and you analyze the data one way and say, I want to run some experiments or play with the data and kind of see what's going on, I can do that. Matter of fact, if I really wanted to play with the data and I'm in here, I can start changing the layouts, or I can come down here. That's right, it's up here. Oh, that's right. I gotta highlight something. It's not gonna let me do it on this. It's got a high frequency data set, should be there. Not clear on what I did. When I'm up here, there we go. And I click ASCII file, that's going to create a CSV of all of the channels. So let's see, this one is 201. For all of the high frequency data set. And that's now done. So if you've got a data scientist or you are a data scientist, you want to play with the data a little bit more. Here. Right down. And here, I just looked down here for a CSV file. There it is. That's the ASCII set I just exported. So I do this and I play with Python and I try to glean additional things we can gather from it. So this is just a stamp for time. This is my data on channel 1, 2, 3, all labeled channel 11s in kilowatts. And then I can go from there. And this is the raw data, by the way. So this is the actual values that it was seeing before it put it through a CT ratio. And you can see there's empty channels. Those are we don't collect that data. So channel 1 through 8 and then 11. If you do the high frequency, if you do low frequency, channel 1 and 2, and yeah, that's it. So this one is, I think this turns into like sizable file. Yeah, 21 meg. Did that provide an answer for you?
Yeah. Yes.
So other than that, I mean, I'd have to go in, you have to go in and manually manipulate the data in order to change it. So yeah, so if you're looking at it and you've got your settings one way and somebody else is looking, they have their settings the other way, they may see some slight changes. When I am in here, by the way, again, if I want to look at certain things, these are zooms. Get in close. These two zooms here, I never actually end up using. This steps you backwards and it's set up so it goes backwards step by step instead of all the way to the beginning. And you'll notice the resolution drops as I zoom in closer. These only analyze what I see here. This is a bad gain setting. So it clipped the tops. That just means additional noise here. I could still analyze that though. And then this, by the way, this tells me the center of this noise here tells me the primary inverter frequency, which would be just under 2,500 hertz. So right in the center that's that, and this is a harmonic of it. And things that relate to the transformer resonance and heating happen in between. So because it's 12,000 hertz, the Nyquist is actually 6 kilohertz, 2, basically Nyquist of 2, so half. And 5,500 is the roll off. So any frequency from 0 to 5,500 with the system you have is good. And you take that, multiply it by 60, and that'll give you what CPM you're going to, if you're talking to a vibration analyst. Basically, there's nothing in the tower you're not going to be able to see with that data set. And if I wanted to just view certain channels, make it less noisy, I could lay these on top of each other. I'd want to change the color a little bit to do that. And if I really think, if I'm really, really stuck on whether or not I have a wiring issue, one of the other things I can do is frequency. And come in here and look at the RMS current, see if I have a sawtooth. That would be the final indication. If ever you see an F, it's because I saw a sawtooth here. In addition to whole pass frequency peaks, dynamic eccentricity, and a certain percentage of the total load in kilowatts in whole pass frequency. So with that, any other questions? Take that as a no. So yeah, so collect data, use the instructions you have if you have to go up tower. Other ways of doing it, if you want to be manually collecting data, I've done things like remote PC or whatever to access a PC up tower or mini computer, whatever. As long as you can power the system and you have communications between two PCs, you're good. I think that's one of the ways we were originally talking, but yeah, the instructions on doing the data, the continuous monitoring data works just as well.
At our instruction,
Yeah,
we ask the operator at the wind farm to put all the setting regarding the wind turbine, the generator, the bearings, and he repeats it every tower he goes up. So by what you said now, they don't need to do all the setting. They just need to collect the data and send to us, and we can set one time and copy and paste to all that data, right?
Yeah, you want to make sure that all the nameplate data is set up the same for all of them when he's collecting
Yeah,
data.
of course.
Yeah, but yeah, that's it.
When he's collecting that?
What's that?
So the nameplate should be set when they are collecting the data or not?
No, you can set it
No,
beforehand.
okay.
Yeah.
Okay, so
I
basically.
normally would set them up ahead of time. Get everything set up ahead of time. It just reduces the amount of time the technician has to do things.
Yeah.
Thank you.
Yeah, okay.
Yeah. Yeah, I mean, if you guys have a way that's working now and you think it's going to be confusing, do the way you're doing it now. It's pretty flexible. What you don't want to do is just have the data on the default all the time, because if you're trying to analyze it, you're having to enter the nameplate each time. So instead of 5 or 10 minutes a tower to analyze, once you start doing it, it's going to take you a half an hour or more.
Yeah.
But when we send you the data,
Yeah.
do you check the nameplate and the
Yep.
data that's set? Okay.
Yeah, I always check. So usually, like, if you send me the data, unless I'm driving to a job site or something like that, I'll go through some of the data and just open it up and make sure it looks like it's supposed to.
Okay.
And then when I can sit down, I'll do that first on all of them, make sure that I don't have any that are bad data. And then I sit down and start from the beginning and analyze. Because it's never any fun if you send me data and I'm spending a couple of days analyzing it. I try not to. I try to do it all in one sitting. But if I spend today working on it and then I spend tomorrow working on it and then I hit into a group with bad data, that's not as much fun to call back and say, hey, you had bad data on these. And then the third day I go back and I find even more. I did that once. It's really annoying to everybody. But yeah, when I get it, I try to look at it first before a system is sent to another site. the one wind company up here that talks about us a lot, I use their name as Clearway. They have multiple of these systems and they ship them from site to site. And when they get to each site, the technician there goes and collects data and then sends the data out. We make sure they keep the data collector there until we get the data and verify that the data is good before it goes to the next site.
Okay.
Yeah, and then you guys are one of the first wind companies that got the carrying case. Everybody else had to make their own. So that carrying case is designed to be able to ship these things around as you need to. Make sure everything is unplugged from the instrument when you package it. We had somebody leaving the USB cables plugged into the data collector. And we got two data collectors back from the same site where during shipping, something had hit the side of the cases and it punched the USB through the card. And we had to repair both. So yeah, just make sure everything's disconnected. It should be okay. There are no other questions. Yeah. Next step will be once we get certain things taken care of, we'll schedule a class and
Okay, I'm taking care of everything so we can schedule it.
Yeah. And we'll be able to go through the 3-day class and it won't be just this stuff. We're gonna go in, we're gonna play with real data. If you guys have your data, I'll pull some data, I'll sanitize it so you don't know who it's from. But we'll look at some real data from other tower types too. If there's a
Okay.
chance that you're gonna see other tower types, including other manufacturers, it's really important because every type of tower has their own idiosyncrasies. So we'll cover some of those as well, so that you can see, hey, I've gone into this, it's our new design, something doesn't look right, but they all don't look right. It's probably just the way it's supposed to be for that design.
Okay, thank you very much, Dr. Howard.
Okay, thank you. And have a great day. And like I said, any questions, you've got free tech support. So drop an email, probably the easiest, or text or call works.
There is a technical support email or